Next comes divergence of vector function. There comes a vector. Divergent vector point means divergent means dir. Okay, divergence of div. So divergence of f vector, which is nothing but del vector into f vector. Like del vector, why I have put del vector? What is the difference for del and del vector? Del vector has the direction like I, j, k values. These are vectors. Okay, but here there is no such values. So this is a scalar. This is a vector because this vector includes a direction. Okay, so del vector into f vector, these two are vectors. If we multiply the two vectors, we will definitely get the scalar function because I into I is nothing but 1. So all the vector terms like I, j, k will be multiplied. It will convert to 1, right? So all these things will go off and only the scalar product will be remaining. Okay, so del vector into f vector, always remember this. Divergence means dive of f vector, with means always remember del as a vector, del vector. So the same applies here. Dou f by dou x plus dou f2 by dou y plus dou f3 by dou z, like f1, f2, f3. We need to differentiate each by x, y, z with respect to x, y, z. So next thing, divergence of f means divergence of f vector, which is equal to del vector into f vector. If this vector is equal to 0 means this vector we can be named as solenoidal vector. If divergence becomes 0, solenoidal vector, it is named as solenoidal vector. This can be asked in the 1 mark questions. Okay, curl of a vector function. What is curl? This is the second topic. Curl of the vector function. Like curl of f vector means the cross. So divergence means dot. Here curl means cross. Okay, dot and cross. Del vector dot f vector. Del vector cross f vector. Okay, cross means what? We need to introduce the matrix term here because it is cross. So I, j, k, these are all vectors. Okay, I vector, k vector, j vector. Okay, these are all vectors. And the second term comes the differential like del. Del is nothing but dou by dou x. And the third term comes the f coefficients, and by solving this, just take the determinant, you will get a vector. This vector is nothing but curl vector. If this curl vector is 0 means it is irrotational vector. Okay, it is said to be irrotational vector, it can't rotate. Next, if v is vector, velocity vector. If v is a vector, this is a velocity vector, and omega is a vector, it is an angular vector, means angular velocity vector means we can write this as v velocity, which is equal to angular into r. Okay, velocity vector which is equal to angular vector into r. We can write this as like this. Here you can see curl of v vector, which is equal to, we know that this is like f vector. Okay, so del into f vector. Likewise, curl of v vector, which is equal to del into v vector, like del cross v vector. So if it is a cross means, you can see here, this is like del cross omega cross r, right? Because this V is equal to omega cross R, right? So del cross omega cross R. Okay, if I do so, I will get 2 times of omega vector. So what is omega vector? Which is nothing but half of curl v vector, half the times of curl of v vector. Okay, so omega is nothing but omega vector, which is equal to half the time of curl of v vector. Okay, and divergence, this divergence, before that we have seen divergence, right? That divergence gives the rate at which the fluid flows. So the fluid is gone flowing, the rate at which the fluid flows means that this rate will be given by the divergence. But here curl will give the rotation. If curl is equal to 0 means it is irrotation. If curl is there means there will be rotation. Scalar potential function. For every rotational vector, F vector is said to be del vector of pi, right? So F vector, which is equal to del vector of pi. You know that pi is nothing but scalar potential function, right? So it is a scalar potential function. Okay, scalar potential function means pi. So you can easily write F vector, which is equal to del vector into pi. Okay, and there comes some properties of vectors, vector identities. Let's see that. Curl of gradient. So a curl of a gradient of pi, which is equal to 0. If you are taking the gradient pi, so if you are taking the curl for the gradient pi means, if they asked a curl of gradient pi means it will always be 0 for whatever be the vector. And the second point is divergence of curl of v vector. First we need to take the curl and then we need to take the divergence, means it will always 0. Third one, divergence of del pi. We are taking the divergence for the del pi, which is always equal to del square pi, because the formula itself we have del dot pi, right? So the function itself have del pi means it will be a square here, del square pi. And the fourth function is what? Divergence of pi v vector means we can just take this as outside. So pi into divergence of v vector plus del pi dot v. So the first thing is we need to take the divergence. Okay, so divergence of pi v vector means just take it out, pi into divergence of v vector, then plus del of pi into just v vector. Okay, del of pi into v vector. And the next thing, curl of pi into v vector means just take it outside, pi into curl v vector plus del pi dot v vector. Whatever the thing, just write the divergence to the v only. For pi you just write del. The same applies here. Okay, whatever may be the curl or divergence, just this formula is same. Okay, curl of curl v vector means just del of divergence of v vector minus del square of v vector. So del of divergence of v vector minus del square of v vector. Okay, next, linear velocity, right? So they have given one form like questions. If the linear velocity del is given by the vector, so linear velocity del is given by a vector, then they need angular velocity. So they have given the velocity vector v. We need to find the angular velocity vector, that is omega. We know that omega is what? Half the time of curl, right? Curl of v vector. Okay, so half. What is curl vector? Curl vector means we need to write it as del vector cross v vector. This is curl v vector. Okay, so curl v vector is nothing but del vector cross v vector, right? So I am just writing I j k here, the first term. Next term is del, dou by dou x, dou by dou y, dou by dou z. Next term is what? V. So what is the v coordinates? X square y, xy z, and y z square minus of. So I am just taking the determinant value here. You can just copy this half here, and I into just multiply these two things. How can I multiply these two things? This is what? Dou y. So with respect to y, I need to differentiate it. So minus z square will come here, and then minus of these two things with respect to z. So xy will come here, minus of j into, just make this as invisible, and you can see here these two cross. So with respect to x, you need to multiply, means you need to multiply, like you need to differentiate this will become 0. And here with respect to z, there is no z, so it will become 0. So z j term will be 0 plus k into these four things, these four elements. With respect to x means y z, minus with respect to y means minus of x square. Okay, x square. So by solving this, and you can see here they have given a points, just substitute x, y, z here, and you will get a vector at last, minus of I plus k vector. Okay, next sum. Directional derivative of f of xy. They have given one function dd, they want to find dd. The derivative of f vector at point, they have given the point. In direction of vector, they have given the n. This is used for the direction vector, is always used for the n cap, right? Okay. Is 2 root 2, and the directional vector of minus j to j is minus 3. So they have given the directional vectors, means dd value. They have already given the dd value of these two vectors, 2 root 2 and minus 3. What is dd? dd is nothing but del f into n cap, right? So I just wrote two vectors here. This one is a vector and this one is b vector. So it is under n cap. Okay. So what is dd here? Directional derivative, nothing but del of f function into n cap, right? So what is this? N cap is nothing but a vector by a modulus of a. They have given the value as 2 root 2, and for same b vector by modulus of b, they have given the value as minus 3. So from these two things we need to find the f function, right? They don't give the f function here actually. So I am just going for second one. So I am just, because it is nearby. So you can see here what is del f. We need to differentiate this f with respect to x, y. There is only 2 points they have given. So x, y is enough. And they have already given f of x, y. So dou f by dou x, I vector, plus dou f by dou y, j vector. This is nothing but del f. What is this? For b it is minus 2j. So I am just written minus 2j by modulus of this coefficient. So modulus of 2 square is 4. The answer is minus 3. Okay. So you can see here only the j is here. So omit the I. So this into this is what? df by dy into minus 2 by 2. Root 4 is what? 2, right? So minus 2 by root 4, that is 2. So you can see here the 2 will get cancelled, and the minus symbol will also, like here is also minus, here is also minus. So the minus symbol will get plus. So dou f by dou is what? Dou y is what? 3. So we have got one equation here. And then the other thing, so by doing so, I will get dou f by dou x has 1. So this is the another thing. So I have got for dou f by dou y, dou f by dou x. Then I am coming to the directional derivative of the direction. So they have asked this dd for this vector. You can see here they have asked this vector. I have written one vector here. Okay, so they have asked for this vector, what is the dd value. So for that I just need to find the other, I just need to use those values by in the other vectors, and then I have to find the two values here, and then I'm going to repeat it in this dd vector. So what is dd vector? Just del is what? This term, del into n cap. Okay, so after simplifying it, we will get this value, right? So I'm just multiplying I coefficient into I coefficient and j. There is no k here, so this term will become 0. So what is it? Minus 1 minus 6 by root 5. You can see here these two terms we have already found, and this is the unknown term. You can include or you can just omit it because they have given only two functions here. So I know this function, I know this function. Just multiply it, you will get the answer. Okay? Yes. Then we'll move on to the next sum. If A is some point, B is some point, C is some points. They have given 3 points which is defined in x, y, x coordinate. Okay. Which are of following vectors are perpendicular to both AB and BC? Which is the following vectors will be perpendicular to these two vectors? So I need to find these two vectors. You can see here B is nothing but only 0, 0, 0 vector. So I need to put this vector after the minus, right? So I'm just writing from B to A and B to C. So here they have given A, B, B, C, but I'm writing B to A and B to C. So 0 OA means O is at origin, right? So we can write this vector as BA vector, which is equal to just OA vector, first with A and then with B. OA minus OB. Likewise here, OC minus OB, which is equal to, I need to create the vectors, right? So just pick the values here. So what? OA means this will become 0, right? So only A vector will have the values. So I can directly write the values here. 4j, this is I, j, k. 4j plus 3k. Likewise here, 3i plus 4k. Right? So I have found the two vectors here. Then the vectors perpendicular to BA and BC. I need to find the vectors which is perpendicular to BA and BC. So I am just taking these two vectors in cross. Okay, BA vector cross BC vector to take the perpendicular. Okay, so if I take so, I will get the determinant value as this. So this is the perpendicular vector which is perpendicular to B, AB and BC. Okay, and you can see here in a question they have given two vectors, means if they asked P dot V, just if they asked what is this two vectors, like they are orthogonal or something, if these two vectors P dot Q, these two vectors, one vector dot Q, like one vector dot two vector will give the answer 0, means these two vectors are said to be orthogonal. Okay, next thing, the direction of vector A is radially outward from the origin. Okay, they have given the they are saying that the direction of A vector is outside the origin, radially outside. Okay, with modulus of A which is equal to K into R power N. And they have given R as R square which is equal to X square plus Y square plus Z square. And K is constant value, the value of N for which del dot A which is equal to 0. They have given these things. Okay. So we know that N cap is nothing but R vector by R modulus of R, because this R vector which is in the direction, which is the directional vector, like which is this R vector, this N cap in the direction of R. So N cap in the direction of R will give the R vector. So R vector by del R vector. Then we will go to the A vector. What is the A vector here? A vector, they have given the modulus condition, right? So modulus of K into Rn. Okay, but I need A vector. This is modulus. So if I into it by N cap, I will easily get the modulus. Okay, so I will easily get the vector. So A vector which is equal to the part modulus into N cap, right? Okay, so after that you can see here this R, I already told you 1 by R is nothing but R power minus 1. So R power minus 1 and R power n minus 1. After that they have given something like del into A vector which is equal to 0. So I am just doing so. Del into A vector, I just take the constant outside, and what is the remaining? R power n minus 1 into R vector, I just wrote here, which is equal to 0. So I need to take this value as I, J, K. Right. Why? Why so? Because R vector is nothing but xi vector plus yj vector plus zk vector. Right. So this is the term of R vector. So you can see here R power n minus 1 into R vector. This things are R vectors, right? So I am just splitting it into 3. K will become 0, so just leave the K. So del of these 3 things. And after this we gonna differentiate it. Okay, what is del? Del means we need to differentiate it. Okay, so we need to differentiate the I part and then the J part and then the K part. So I just written here which is equal to 0. Okay. Okay. So here you can see here dou R by dou X. Okay. So I am just differentiating each term. This is like what? U and V. Right. So what is UV the whole dash? UV the whole dash which is equal to U dash V plus UV dash. Right. So this is U. So I am gonna differentiate the first thing U. Dou by dou X of this thing. So I am just differentiating R. So I just write dou R by dou X because R with respect to X, right? So I am just writing here dou R by dou X which is equal to this power will come front. So we need to put the power in front and minus 1 in the power. Power முன்னாடி கொண்டு வந்து பவர்ல ஒன்று மைனஸ் பண்ணும். If we minus 1 to the power means the power will become n minus 2, right? So n minus 1 into R power n minus 2 into X because this is V. So I have done the U dash and then V plus U. V dash is what? X. X. If we differentiate X, it will become 1. So I have finished the V dash. Plus the same applies here. The same thing, you can differentiate these things. And you can see here these 3 terms are same. So I can write it as 3 times of R power n minus 1. And in these 3 terms, the 2 things are common. Just take this as outside. Let's see that thing. And you know, dou R by dou X. So if this is R vector, right? This is R vector means dou R by dou X is what? just a reverse one, x by r, y by r, we have already seen that thing. Okay, so you can see here 3 times of r power n minus 1 plus, I just took the two values in the outside, and you can see here there comes r. So if this r came here means r power minus 1, so r power minus 3, it will become r power minus 3. This term is what? R square, right? Okay, so this is r square. So r square means I need to put, just make this simplify it. So this bases are same, I need to add the power, so n minus 1. Okay, I'm just taking this r power n minus 1 as common, it will go there, it will become 0. So 3 plus n minus 1, which is equal to 0. What is n minus 1, which is nothing but minus 3, that is n is minus 2. So they asked us to find the n value. Okay, let's go to another sum. The divergence of the vector field, they have given one vector, is what? They have asking a question here. You don't need to confuse here, this is like I, j, k only. Okay, you don't need to consider how can I differentiate ax, how can I differentiate ay. No need to confuse this, because this is I, j, k, right? So divergence of a means nothing but del a, right? So we need to differentiate with respect to x, y, z, the a coordinates. So I am just doing so. Dou by dou x of ax, dou by dou f of y, dou by dou f of z, right? So you can see here this will become 1 1 1, because 1 1 1, if we differentiate x means it will become 1. So 1 plus 1 plus 1 is 3. This can be asked in the 1 mark questions. This is actually asked in the gate. Okay, now we're gonna see only the gate questions. The curl of gradient of scalar field defined by a vector. They have given one vector. I already said to you, curl of gradient of scalar field. Curl of gradient is nothing but 0, right? We have seen this in property. So the value will be 0, whatever may be the vectors. If r vector which is equal to x into, so they have given one vector here, and modulus of r is r. They have given one condition here, modulus of r is nothing but r. Divergence of this value, we need to find the divergence of this value. Okay, let's see that. So let's take this vector and we need to take this del, like f of r. We just take this vector as a function f of r, del of f of r, which is equal to what? What we will do for divergence, this is nothing but divergence of f of r. Okay, divergence of f of r is what? Del of f of r. So what will we do if we put del means we need to differentiate it. So f dash of r into, what is this? N cap, new unit vector. Okay, which is equal to, we know the unit vector is what? R vector by modulus of r. They have given r means modulus is r. So just write r here. And I am just taking, they have given del of log r. So I am just taking the function as log r. So del of log r, which is equal to f dash of r into r vector by r. You don't need to cancel these things, because this is scalar one, this is vector one. So okay. So then what is the differentiation of log r? Log x is what? If we differentiate log x means it will give 1 by x, right? So likewise log x means 1 by r. You can see here the another r is here, so I am just multiply it 1 by r square. Okay, 1 by r square into r vector. So I am just taking this r vector here. So if I take r vector here means I will get this value, right? So this value will be equal to, sorry, whatever may be the thing, just bring this here. So this value will be equal to what? R vector. So simply R vector. So divergence of this value which will be equal to divergence of r vector. We already know the divergence of all vector is 3. You can see here y means if this r vector is like this in this form, they have given like this only, right? X into x, y into x. So if this is in this form, whatever may be the form xi vector, yj vector, k vector means if we take the divergence like del, this is nothing but del of r vector is always be 3, right? So x will become 1, if we differentiate x it will become 1, for y it will become 1, for z it will become 1, so addition will be 3. Okay, let's see another great questions here. The great question, let del of fy, so they have given a function, f is a function and v is a function. So del dot fv, which is equal to, they have given one condition, one term here, where f and v are a scalar and vector fields. As I told you, these two are different, right? So f is a scalar and v is a vector field respectively. If v vector, they have given one vector, then we need to find v dot del f. Okay, just take this. I'm just gonna start from this. Okay, they asked this one, so we need to find this. What is what? Okay, just I'm just starting from this. Del dot fv, which is nothing but which is equal to, just take the f outside and make this 2 multiple f into del dot v plus v, just take this as outside, v into f del dot f, right? This is a function, this is a equation. So just take this v as outside, sorry, f as outside. First of f as outside means f into del dot v, and v as outside means v into del dot f. So this is a function. So you can see here they have asked the second term. Leave this. They have asked the second term. Okay, what is v vector? They have given this vector. So here we need to find the del v, right? So I'm just finding the del v. You can see here y, I, z, j and x, k. There are different variables here. Like if I differentiate the I coordinate coefficient only with the x, right? So with respect to x means this will become 0. With respect to y, this will become 0. With respect to z, this will become 0 because the variables are rearranged. So the vector del v will be 0. If it is 0 means this term will also be 0. So what is what? This term is equal to this term. So you can see here this term they have already given in the question. So they have asked only the same term. These two terms are equal. Okay. Let's see the another one. This is the last one. Vector integration. So we're gonna see that line integration in this topic, and then surface and then volume. Then the three theorems will come under these things, and it will be the end of this video. Okay. So vector integration, line integration. Line integration is what? Integration along or over the curve. So along the curve or over the curve there will be an integration. It is called line integration. And this line integration which is equal to f into dr, right? So they have a formula here, integral of f into dr. From up to this we have seen only the differentiation. So divergence, gradient, curl, all comes under the differentiation. Line, surface, volume will come under the integration. Okay. So line integration which is equal to f vector into dr vector. Okay. What is this C? C is a curve. So curve. Along the curve there is a integration which is nothing but line integration. And they have given one note. If C, that curve, is a closed curve means then The line integration of f over c is called circulation of f. So the line integration over the c is called circulation, because the curve, if we say this as a curve, means this is a closed curve. You can see here this is a closed curve, means the line integration along these curves will be a circulation, will be a circular one, right? So that is what they are saying. That is means you need to put a 0 like this in the integration. So this is a circulation, circular integral. That's it. There is nothing different here. The integration will be in a circular order. Okay, circulation. Work done by the force, which is nothing but the line integration formula. Same here. Force into distance. So force into distance, like dr is a direction. Okay. So work done by the force is the same formula. There comes the another note. If f vector is irrotational, okay, here we have seen the rotational. If it is irrotational, means then this f vector into dr, like they have limits, can be written as the function pi function of upper limit minus pi function of lower limit. This function is nothing but scalar potential function. So we can written this line vector as two functions, the same function with upper and lower limit in the subtraction. Okay, so let's see one sum here. F, they have given one f vector and they need us to find the f dot dr. This is nothing but line function, line integration. Along the curve, they have given one curve and they have given 2 points. Okay. So what is f dot dr? Okay, what is f dot dr? F dot dr, which is nothing but we need to differentiate the first term with respect to x and the second term with respect to y. So the same here. They have given one dr here. But in the previous sum, we always put dou r by dou x and dou r by dou y. But here, they have given dr, like dr by dx. But here, they have given the dr. Only we need to put the dou x. So, we need to differentiate it like into. We need to put it into dx. Because the dou dx is here. Let me say dr by dx means, if dx in the right hand side means this will go to the left hand side, right? Sorry, if dr in the left hand side means this will go to the right hand side, right? So f dot dr, which is equal to the dx dy, will go to the right hand side. So the first term into dx plus second term into dy. We know that r vector is what? Xi plus yj plus zk, right? So, you can see here y, which is equal to x. Actually, they have given the curve as y, which is equal to x. So, instead of y, I can return x, right? So, I am just returning this as y equal to x means dy is what? Dx. So, I am just substituting these two values here. Here is what? Y into dy. This is the previous step. So, the integral xy dx, I am just replacing it as x into dx, right? So, I can see here x square, here xy. So, 2x square, 2 times of x square in the integral. And then I am just differentiating it. I will get 2 by 3. Just the same here, same integration, but they have given dr here. We need to put dx, dy, dz as a multiple, okay? Next sum. They have given one function here. This is a circulation. Okay, they have given one function and they are saying C is bounded. C is what? Curve. So the curve is bounded by y equal to x, right? So y equal to x and y equal to x square. So this is a curve. This is curve and this is straight line, right? This is straight line and this is curve. So I'm just drawing a curve y equal to x square. So this curve is what? So this curve is what? Y, which is equal to x square. And this straight line, I'm just drawing the straight line here. So I just need to take x and y values same. So I'm just taking 1, 1. So I'm just drawing along the line point here. So this one is what? Y equal to x straight line. So you can see here I have got 1, 1 and 0, 0. So I have got the limits here. And the main thing is this point, this point. So from this point to this point is what? 0. This point is what? 0. So OA. Along OA it is curve. Along AO, you can see here along AO it is a straight line. So this is a curve and this is a straight line. You can see here OA is curve and AO is straight line, and I have got the limits here. Okay, just concentrate these things. OA means the limit will be 0 to 1. AO means the limit will be 1 to 0. This is most important thing actually. Okay, so this is important one, 0 to 1, and the limit for AO is 1 to 2. Okay, so along OA they have given the function here and we need to find, just differentiate these things, that's it. Okay, so I'm just taking the curve equation and I'm just differentiate it. I will got the dx y value and dy value. So I'm just substituting all these things and just simplifying. I will get the answer as 19 by 20. The main thing here is I'm just giving the the limit as 0 to 1, right? So I'm just giving the limit as 0 to 1. Then the next thing, along AO, like it is a straight line, so I'm just taking the straight line equation. I'm just finding the dy, which is equal to dx. So the limit is what? 1 to 0, because the straight line A and 0. So A to O means the straight line comes here and the curve goes here. So here 1 to 1 and 0 to 0, right? So you can see here 1 to 1 and 0, 0. So A to O means 1 to 0 is a limit. So 1 to 0 is a limit. So the same thing here, just substitute y and dy and just differentiate it, and this is a limit like 1 to 0. Okay, so you can get the answer as -1. Okay, this is an important sum. Next we gonna see the theorems. These are very important theorems. There are 3 theorems, Green, Stokes and Gauss. These theorems are very important and it is dead easy too. Let's see that. Just you need to remember the formulas. Remaining things we need to substitute the values in the formulas like vectors or whatever may be the thing. Substitute these values in the formulas, you will get the answer. What is Green's theorem? Green's theorem has 2 vectors. So they have 2 functions, m function and n function, which is of xy functions, which has xy. Okay, so or a continuous function means in a closed region bounded by a simple closed curve, means we can write this Green's theorem, these 2 functions, as integration of c m into dx plus n into dy can be written as 2 times of r, like the integration, 2 times of integration, double integration into, just see here, dou n by dou x, so n to x, and then dou m by dou y, so m to y, just an opposite thing. Just remember these things, it's a trick actually. M dx plus n dy, which is equal to dou n by dou x and dou m by dou y, this is a thing, into dx dy. Okay, so the relation between line and double integration is the Green's theorem. So this equation gives the relation between the line and double integration. You can see here this a line and a double integration. So this comes under Green's theorem comes under line integration. Okay. And next is Stokes theorem. Let say S be a open space, open surface. This is very important. It can be asked in the gate question actually. Open space. Whenever the question asks to open space means you have to substitute the formula Stokes. So let S be the open space, open surface bounded by a simple closed curve. This is a closed curve. Okay, open surface and a closed curve. Okay, so in a closed curve, this is important, open surface. Then integral f vector into dr vector. This is actually the line vector. Okay, f vector into dr vector, which is equal to double integral of curl of f vector into n cap. So just find all these values, just substitute here, you will get the value. That's the thing. The formula is somewhat lengthy. Okay. Double integral of curl of f vector into n cap into ds. So the relation between line and surface. This is the relation between the line and surface. You can see here. So this Stokes will come under surface integral, right? This Stokes will come under surface integral. Okay, so the formula is f into dr, which is equal to curl, double integral into curl of f vector in dot n cap. Okay, and the last one is Gauss divergence theorem. After that we will see some important gate questions, gate problems. After these three theorems, this is important up to this vector calculus is completed. Okay, let's see that. Just a few more things of that. Just see that. Gauss divergence theorem. So here their surface is a closed surface. If they say closed means you have to apply the Gauss. If they say open means you have to apply Stokes. Okay. So let S be closed surface. Then double integral into f vector dot n cap into ds will be equal to del dot f vector into dv. So del dot f vector into dv. This is a formula. So double to triple integral. Okay. So let's see some problems related to these three theorems. So the first question is value of the integral. They have given one integral. So they need value of this integral where C is what? The curve. So where the curve is square cut. So the curve is in square cut from first quadrant. So it is in first quadrant by the line x equal to 1 and y equal to 1 will be what? So they need value of integral. And they had given line to surface integral. Line to surface is what? The first one. Line to surface. Okay. So we need to go for the first one. Okay. So you can see here line to surface. Don't need to confuse here because they have given the means integral as in the form m n. Okay, m into dx and n into dy. So they have given the integral in this form. So you need to go for Green's theorem. Okay, this is according to the Green's theorem. So I have written the formula here, and here the important thing is in the graph they said first quadrant. So what is the first quadrant here? So both will be positive. Okay. They said x equal to 1 and y is equal to 1. So I am just plotting x as 1 and y as 1. And I am just connecting these two lines. I will get 1, 1. Here I need to tell you one thing. If this line is y equal to 0 means what is this line? This line will be y equal to 1. So the distance is 1. Here x is 0 means what is here? X equal to 1. The distance is 1. Okay. So I am just written the formula here. This is the left hand side part which is equal to this function. So as I said, m is equal to y square. Okay. So m is equal to minus y square and n is equal to x y. So I need to find the right hand side, that is double integration of n with respect to x and m with respect to y. So m with respect to y. So you see here m to y and n to x. So what is y square with respect to y means 2y. What is xy with respect to x means only y. So what is the integration value here? 0 to 1, 0 to 1. Okay. So you can see here this is the term. After that we need to put the integration values like integral values. Okay. So after differentiation I have write the value here. You have to integrate these values with respect to y and x. So the differentiation value will be m with respect to y means what? Minus y square, right? So if we differentiate this with respect to y means you will get 2y minus of 2y. You know here there is a minus here, so plus of 2y. Then xy with respect to x means what? Only y will come. So y plus 2y. So the total is 3y, right? So 3y into dy dx. So I need to integrate this value. I am just taking 3 as outside, and if we integrate y means y square by 2. How? Power la one add panni same power ala divide pananum. So y square by 2. Right, what are the integration values? 0 to 1, right? So 0 to 1. So it will become half, and then I am just taking this half as outside because it's a constant. Then dy. If we differentiate dy, it will come as x, right? So x power 0 to 1. So the value will be 1. So I just emit this. So value will be 3 by 2. This is the answer. So the next question is, if r vector is position vector of any point on closed surface. Closed means we need to use Gauss, right? Surface, yes. That encloses the volume. Then double integration of r vector into ds will be what? This is what the left hand side of the Gauss. You can see here. So the Gauss is what? Double integration of f vector into n cap, right? So the same here, f vector into dr. Okay. So they have given these things, and we need to find the left hand side. So we need to find this left hand side. So triple integration of del into r vector into dv. Okay. So del into r vector means what? Let's take the r vector as, xi, yj, zk. If it is del means it will become 3, right? 1, 1, 1. So it will become 3. So just take this 3. Del of r vector is what? 3. Take this 3 as outside. So 3 into this one. So integration of dv is what? Only v. So 3 into v is the answer. Okay, it's just simple. This can be asked in the 1 mark questions. If a vector, they have given one vector, then they have asked a vector into dr over the path shown in figure. So they are asking a vector into dr. So let's go to the theorem, Green's theorem. M into dr plus n into dy, which is equal to double integral of n with respect to x and m with respect to y, right? This is the question. This is the formula. So they have given a graph. This is already shown, okay, in the question. So you can see here x limit is what? From this to this. 1 by root 3 to 2 by root 3. 1 to 3. Okay. So I am just making this. You can see here this is m and this is n. I am just substituting here. I will get this form, right? So with respect to n with respect to x, this is n. With respect to x means x square. Power munani kondu power la one minus pannum. So 2x. Just bring the power before and minus 1 in the power. So 2x. And then here with respect to y, right? So xy with respect to y means only x will come. So 2x minus x into dy dx. So the terms. So you can see here y term, y you means y's limit is what? 1 to 3. And x limit is, dx limit is what? X limit is what? 1 by 3 to 2 by 3, right? So just differentiate this term. You can see here 2x minus x is x. So we need to differentiate this. Just if it is y means just take this x as constant, right? So I am just taking it as constant. So what is dy? Will be y. If we integrate dy, it will be y. The value is that limit is 1 to 3. So you can say it upper limit minus lower means 3 minus 1, it will become 2. So here 2. So I am just taking this 2 as outside. Then integral 1 by root 3, 2 by root 3, right? So you can see here x. If we integrate this x means power la one add panni same power alla divide pannum. So add 1 to the power and divide the same power. X square by 2. This 2 will get cancelled. And x square. If we put this means upper limit minus lower limit, right? So if I put upper limit means 2 square by root 3 square is what? Root 3 square means this 2 and this root will get cancelled. 3 will come. So this is upper limit minus lower limit, which is equal to 1. So after the answer will be 1. Next sum. Consider the closed surface surrounding the volume V. So what is the question they have asked? This one. So they have given the vector in the term this. So just find the left hand side, you will get the answer. That's the thing here. Okay. Whatever may be the thing. What is the left hand side they have given? Just choose the theorem and then substitute the values. You will get the right hand side. Okay. That will be the answer. So the surface is S, right? It's a closed surface. Closed means gas. USS, gas. Surrounding the volume V, if a R vector is a position vector of point inside with n cap on S, then the value of this one, so it is like the left hand side, okay? So what is the formula? F dot n cap, double integration of F dot n cap will be dx, which is equal to triple integration of del into F. This is the actual value. Let's take F as this one, xi plus yj plus zk. Okay, this is nothing but the R vector. Okay, let's take this R vector as F vector. So from this they have given the left hand side, 5 into R vector into n vector. You know F vector which is equal to R vector, right? F vector which is equal to R vector. So they have given in the question like F which is equal to 5 into R, means 5 into this one, right? This one. This is nothing but F. So they have given 5 into F. This is question. This is formula. Don't need to confuse. This is formula. This is given in the question. So which is equal to 5 into triple integration of del of r. So they are replacing it f by r. Okay. So 5 into del r, like they are returning this function as f here. Okay, replacing the f. After that, you know del r is what? 1. So 1 plus 1 plus 1 is 3, right? So 1 plus 1 plus 1, which is equal to 3. This is del r, right? So this will become 3. I'm just taking this 3 as outside. 5 3s are 15. This differentiation, integration of this dv is v, right? And the next question, the following surface integral is to be evaluated over the sphere for given steady velocity vector field. They have given one vector. I am just taking this as r. Okay. This vector is defined with respect to Cartesian coordinate system having I, j, k as unit base vectors. They have given one vectors here. This is the left hand side. Okay. So it is Gauss, right? So I am just using the Gauss here, which is equal to 1 by 4 into triple integration of the value, like del into f vector is what? R vector. So I am just writing f vector is, which is nothing but r vector, right? So I am just writing del r into dv. So we know that this will be 3. The value for del r vector will be 3, right? So I am just taking 3 as outside. So if we differentiate, if we integrate this means we will get v, right? This v is what? Volume of sphere, which is nothing but 4 by 3 pi r cube. So 4 by 3 pi r cube. Just these will get cancelled and pi r cube will come, where here r, which is equal to 1. How? Which is, you can see here they have given x square plus y square plus z square equal to 1. That is nothing but r square, which is equal to 1, right? So this one is what? Sorry, r. What is r? R is nothing but x square plus y square plus z square. So r is equal to 1. Just substitute here and you will get pi. That's it. Let's see the last sum. Okay. So integral of some vectors, they have given one function here, is evaluated along the circle. They have given one circle transferred in counterclockwise direction. You can see here this one is like n and m, right? If it is in this form, you have to use the Green's theorem, right? So from Green's theorem, I have written the formula here. You can see here. So x is what? X is what? N. Okay. And y is what? M. Okay. So m with respect to y means it will become 1. Okay. And then n with respect to dx means it will become minus 1. Okay. Yes. So minus 1, which is minus 2, and this one is what? This one is the area of circle. So differentiating dx and dy will be the area of circle. Okay. So this is area of circle. So you can see here, what is this area equation they have given? X square plus y square, which is equal to 1 by 4. Right. So from this thing, I am just taking r square. You know that r is what? R, which is equal to x square plus y square, right, plus z square. This is r. So r square means x square plus y square, because there is only 2 terms they have given. So you can directly take r, which is equal to x square plus y square, like r square. This is for circle. Okay. So what is r? They have given 1 by 4, which is equal to x square plus y square. So r square, which is equal to 1 by 2 square. What is r? 1 by 2. So I am just substituting r square value here and I will get half. So which is equal to minus pi by 2. So up to this 3 theorems, which is important theorems, or clear or completed, and the vector calculus is completed. This video covers one chapter, right? Vector calculus. And the next video I'm gonna take, like, I'm gonna give some tricks for what? Tricks for root. Don't forget that we can take square root for any number. So I'm gonna tell the tricks for that. Okay, just see the videos and keep follow all these means all the videos. Just read all the videos. It will be very useful, as I am reading for my exams too. Thank you so much for watching. And if you have any queries or anything you want to ask me, just give me the comments. Okay, I will ready to solve your questions. Okay, thank you so much for watching. Thanks.